All right, so welcome back from the break, everybody. We're going to proceed with our first working group, but before that, we just wanted to mention that there were a few questions that came in the Q&A that absolutely we will make recordings, all the recordings available from the whole summit, so both days, as well as we will follow up on some of the wonderful questions that came in via blogs, particularly on some of the specific topics that we have available. So no worries, and we were able to address a lot of the questions. The ones that we couldn't, we will address them during this follow-up. So as we go through the rest of these sessions, please do keep the questions coming. We want to keep that conversation going. So what we're going to do in this first working group, we're going to focus on drones. And you heard Jarlath mention earlier that drones have democratized the way we do remote sensing, and they have presented so many wonderful opportunities in recent years, but also some challenges along the way. So what we're going to do in this session is kind of discuss and take a look at what are some of these challenges and some of these opportunities, and the way the working groups are structured. So we have a team of experts. So we have someone from the academic community. We have a couple of subject matter experts as well that are going to help with this discussion, as well as help address the questions that are coming in the Q&A. So again, please do keep the conversation going. And the moderator for this session is going to be Dr. Lane Graham. She is a solution engineer at Esri on the national government team. And along with all of her experience, she is a certified FAA UAV pilot. She's a social scientist. She's also a Smithsonian Research Institute, and she's going to lead us through this session.
Thank you so much, Jerry. I'd like to introduce our team today. We have the privilege of having a couple of experts with us. We have Dr. Jarlath O'Neill-June that I'll let introduce himself. Jeremiah Johnson is our technical expert, and we also have Nico that will be monitoring the chat. So Jarlath?
Hey, great. Hey, thanks, Lane. Wonderful to be with you and the Esri staff here. So Jarlath O'Neill-June, Director of the Spatial Analysis Lab at the University of Vermont. You may remember me from the lightning talk several minutes ago. Established our UAS, or drone program, here nearly a decade ago in response to a major tropical storm that damaged our state. And I felt we really didn't have the remote sensing assets we need. And now I do everything from conduct research on the role of UAS in disaster response to running workshops and educational programs from K through 12 through undergraduate students all the way up to working professionals.
Thank you. Jeremiah?
Hello, everybody. I'm Jeremiah Johnson, and I'm an imagery solutions architect here at Esri. I got my start in the manned aviation field doing manned mapping, then got into unmanned. I hold a pilot's license as well as a remote pilot's license, and I work out of Esri's Berkeley office.
Thank you. Nico?
Hi, everyone. I'm Nico Bonafu. I'm part of the imagery and remote sensing team, the SiteScan ArcGIS product team based in San Diego, California. I'm also a remote pilot and a certified flight instructor for manned aircraft. And I'll be answering your questions over chat today.
Thank you. So Jarlath, I'm just curious how drones have fit into your educational curriculum and how your work with drones and education and research have really come to be.
Yeah, I mean, talk about an exciting opportunity, right, Lane? The fact that we can now introduce students to remote sensing data acquisition all the way through to data processing to serving these up in web apps. And I'm just amazed when we run these sort of middle school workshops, and in a couple days we can have kids collect data with drones and then produce a web app showing a map of their school and bring in ArcGIS online services to look at how it's changed over time. I think it's so exciting for us in the learning community, but of course a lot of challenges as well.
It's so inspiring to have you here to talk about how that's fit in the practices and policies and best practices to impart to us all. At this time, I'd love to poll the audience to see how you all are engaging with drones in education. So please take a minute to answer the poll that's on your screen. We'll leave it up here for about 60 seconds and then talk through some of your responses. We're excited to see how many participants here are engaged in both research and education, and just really understand some of the challenges that you all are facing that we could speak to today in terms of implementation and some of the challenges that we can address with our hardware and software as well. Just a few more seconds left on the poll. Awesome. So in terms of our first question, are you teaching a drone program course or course module? It seems that most haven't decided yet, but a fair number of you already have a program going or planning on implementing one within the first year. And so Jarlath, I'd turn to you now and just ask, for those that haven't decided, could you walk us through some of the challenges that you've had in terms of implementing a class or a program?
Yes, and thanks, Lane. It's great to see so many people have. And for those of you that haven't decided, I think it's very worthwhile, but it's not without its challenges. And the challenges, I think, encompass a number of areas. First, something that I really didn't anticipate was the risk management side of things, specifically within our institutional bureaucracies, right? You're going to have to likely look at, first of all, do you have insurance to fly your drones? Do you need risk management approval, right? How is your institution going to handle these things? And many universities, we're just close to airports and we operate in controlled airspace. Then you're going to have to manage your equipment, your battery fleet, and you're going to perhaps look at needing licensed and trained personnel who can supervise these operations. And that's before we even get into the geospatial aspects, which is where a lot of us want to be.
Absolutely, thank you. And in terms of participants that have engaged in drone research or are thinking about implementing one, how would you kind of say in terms of the research versus the education apportionment, how might those be complementary?
Yeah, we were really lucky. In our case, we were able to get research funding, and that's where we started with our drone program. And that really allowed us to make a lot of mistakes earlier on that I think were less critical than if they were in an educational environment, and to develop those expertise and to get through a lot of these institutional roadblocks that we had along the way. I think those roadblocks are being removed, and there's certainly good ways to go about it in starting from the basic level. And the other nice thing now, right, is compared to when we got started a decade ago, the cost of these platforms has dropped considerably. The great work that you folks at Esri have done on the software solutions have made it easier to incorporate drone technology into your curriculum.
Absolutely, thank you for that. And in terms of the final question, what challenges did your institution face in implementing a program? Lack of trained personnel, hardware, software, education materials for the course, institutional supporter policies. Do you have any tips or imparting words, Jarlath?
Yeah, I think I answered yes to all of those. And there's a number of things that I think I've really benefited here at our university. One is having a dedicated staff member who is our UAS lead. And that has helped us throughout our program, right? Someone who can really keep track of the systems, who knows the regulations inside and out. Second was really just getting in with our risk management folks and finding that we could be also useful to other groups on campus and using our flights for them. And I think that led to a sense of trust and building that collaborative relationship. And then to the extent possible, leveraging our existing sort of hardware, software, and IT infrastructure, and not really thinking that what we're doing with UAS is any different. And we had those hurdles early on where people would say things, well, we need regulations on campus to ensure that people don't fly drones near to the dorm windows. And I said, well, don't we just have a regulation that sort of bans any imaging in that particular case? And so I think pushing back and making sure that we don't reinvent the wheel when we can leverage existing policies.
Absolutely. And that brings me to a question for you, Jeremiah, in terms of ways that we can kind of help as a company to enable. What are our drone solutions that we have available today?
Yeah, to help answer that question, Lane, I'm going to share a slide that I have prepared, kind of talking about two of the solutions that we're promoting in this space. The first you might be familiar with, which is ArcGIS Drone to Map, which is desktop drone imagery processing. So this gets installed on your desktop computer, your laptop. You can take it out into the field and pop the SD card in from the drone, process data offline. However, something I want to talk to you about, talk to all of y'all about today is SiteScan for ArcGIS, which is relatively new to the Esri ecosystem. It's cloud-based, scalable drone processing. So if you are looking to take processing from single computers up to scale, maybe you have multiple students or researchers all processing data at the same time and want a single place to store that data, that's where we really want to offer SiteScan as a solution to that problem. Something else is that both Drone to Map and SiteScan for ArcGIS have special education pricing. So, if this is something that's interesting to you and your organization, this is something we certainly want to talk to you about, as we really think that SiteScan for ArcGIS and some of the more scalable enterprise tools that we have available within the cloud solution could really move the needle in terms of how educators are using this.
Awesome. Thank you so much, Jeremiah. That's important to have just an idea about the solutions that we have available. And in terms of the challenges that might be faced, Jarlath, and implementing this and in the classroom, could you kind of describe just the lessons in the curriculum side of teaching these students and researchers how to use drones and program policy consideration?
Absolutely, Lane. And I think early on where we found the real challenge was sort of botnology overload, right? And so we were using different apps to do flight checklists, and then different apps to go ahead and check the airspace, and then different apps to go ahead, or different procedures to submit things to risk management, other software packages to process the data. Each drone had its own flight planning software and execution software. So there was just so much going on, right? And this is what I talked about in my lightning talk, this overwhelming sense of so much botnology and just trying to figure out all these different applications rather than doing the sort of deeper learning, if you will, to get into it. And I think what's really exciting about some of the Esri solutions sort of are how you're envisioning the end-to-end things in terms of going from the planning stage, right, of your flight, and maybe you need to ensure that you assign the appropriate personnel, all the way through to managing your equipment, which is crucial for drones when we're dealing with lithium-ion batteries and you want to make sure you're maintaining your fleet. So I think, Jeremiah, I'll turn it over to you to maybe you can give some sort of insights, especially in terms of the new packages that you folks have available that I think many educators are not familiar with, on how you're developing these software packages to allow people to more easily go from flight planning all the way through to data processing.
Yeah, thanks, Jarlath. One of the things that we realized quite quickly is, you can have the best processing system in the world, but if you have garbage data coming in, you're going to get garbage data products coming out. And so to help assist our customers, we have a flight planning application that can be used for both the Drone to Map local processing solution as well as the cloud solution. And again, I have a slide here. I'm just going to share my screen really quickly to kind of run through this. But this is the SiteScan flight planning application. It's an iPad app that's connected to the cloud. And you can see here we have different flight templates that pilots can use to create a variety of different flight modes or methods of capturing data as simple as possible. And what we've done here is we've created some tried and true overlap settings, side lap settings, elevation settings to help ensure that our customers are getting the best data products out of the images that they're collecting. Because it's cloud connected, the flight plans that one person creates on one side of the world can be executed by somebody else on the other side of the world. Just as long as they're both in the same organization, they can execute each other's flight plans. This is also a field data management platform. Those of you who have gone out and collected data in the field know that you're not just one flight and done. Usually you're doing multiple flights, maybe different flight types, different elevations, or altitudes. And the worst part is coming back to the office with an SD card full of 3,000 images, and then you have to sort out which images go to which flight. One thing that SiteScan does is it associates the images that were captured. It knows because you flew this flight plan, and it knows which images it took for that flight plan. It's going to automatically associate each batch of images with each flight, which will make processing the data a lot simpler. It's also keeping track of your fleet. So something that Jarlath mentioned is it's very important to know, when you're moving up from 1 drone, 2 drone to 3, 5, 10 drones, fleet management becomes very critical. Which drones are flying where. Are there, maintenance that's going on with the drones? Pilots, are they certified? When do their certifications expire? Are the drones registered? All these have become very important, and this is something that we want to make as automated as possible within SiteScan. And of course, with organizations like Jarlath mentioned, having anytime illegal gets involved, it can put a speed bump or maybe a wall in front of you when you're trying to create a drone program. One thing that we're trying to make really easy for our organizations is establishing, safety as a priority. So one of the things is creating a mandated pre-flight checklist form. So that's unique to your organization, that comes up anytime you intend to take off. You have to fill out the checklist, and that checklist gets saved in the cloud and can be exported, reported on, etc.
Thank you, Jeremiah. So there are a couple of questions coming in through the chat, and I'm going to kind of consolidate them here for Jarlath. So some of the questions are around what types of sensors do you recommend to start a remote sensing class? And then kind of how can you utilize the drone data that you're capturing? What types of imagery products are coming out for your work in the education realm, Jarlath?
Yeah, and I think especially those of us like me who come from sort of, I would say, more hardcore remote sensing backgrounds, one of the mistakes that we can make is really focusing on sort of high-end sensors, right? To think that we need multi-channel, multispectral sensors or hyperspectral sensors, and we lose a lot of the perspective on what the true value of drone technology is, which it gives us very high spatial resolution and very, very high temporal resolution. And what we found in our work is that this opens up just a whole host of amazing opportunities. You can just take, say, invasive species mapping, or looking at other species and flying at the appropriate time and green up in the spring or during leaf senescence in the fall. You can see so much detail. And in addition, with the spatial resolution, we can often tell species by their morphology. And I find that's incredibly useful in teaching our students some of the key principles around things like forest type interpretation, things that we have perhaps in the past looked for multi-channel sensors. And so I really encourage people to sort of be very open in using some of these low-cost products out there that we can quickly fly, we can easily process, and we can turn into orthorectified imagery. One of the challenges that we face when choosing drone platforms and drone sensors is that very low bar. We can get in with some great products, and then as soon as we want to jump into the multispectral sensors and RTK GPS accuracy, you're going to pay for that, and you're going to pay a lot more. But you can do so much with those low-cost systems.
And to that, Jeremiah, could you just provide an overview of what types of sensors that we support in our photogrammetric processing?
Absolutely. So in both our local and our cloud processing options, so both Drone2Map and SiteScan for ArcGIS, we support your classic RGB imagery. We support multispectral, so 4-band, 5-band imagery in both platforms, as well as thermal imagery for mapping. And to kind of piggyback on what Jarlath had said, as those of us who started in the industry early on, RGB was relatively expensive. I remember when we were putting low resolution GoPros onto the bottom of drones to try to collect imagery that way. And as the technology has advanced, as the hardware has scaled, we've seen obviously the cost come down. Multispectral used to be a lot more expensive than it is today. And I think we're going to see the same with a thermal, and then eventually perhaps hyperspectral once the weight and the cost comes down pretty significantly.
There's another question that's come in that I'd like to pose to Jarlath here. So Greg's asking, he has a number of challenges managing data in classes where students are collecting and submitting lots of drone data and projects. So the question, I guess, to you, Jarlath, initially, and then perhaps to Jeremiah, are there features both in your curriculum that you've implemented and then in SiteScan to Jeremiah that could kind of help with the management of multiple data layers that are streaming in and projects from students.
Yeah, and I'll just echo sort of this struggle, and especially when early on in our curriculum we were very much focused on desktop processing, right? We would go out and fly, everyone would come back, and then they'd process the data on their workstations, and the only solution we could find is that we just got to make sure we time this with lunch, and then you run into IT issues where you find out if someone doesn't log into the computer, it resets and kills the session. So I think some of the exciting stuff that we're seeing now are cloud-based solutions, which are much better suited for our educational environment, where students can kick this off, perhaps let it run at night or when they're not active, and step away. So Jeremiah, I'll turn it over to you because I know there's some really cool stuff coming, or actually is available right now within SiteScan.
Yeah, the SiteScan was developed first and foremost to solve this problem that Jarlath is talking about, where we had customers that wanted to that needed drone imagery, that saw the value in drone imagery, but had a multi-point solution. They had a drone and maybe a flight planning software over here, and maybe processing software over here, and then a Dropbox or a Box account to upload data to share with their colleagues. And so that was the initial problem that SiteScan was built to solve, was to try to create this streamlined pipeline. And one of the ways is by putting it into the Amazon cloud. We actually have we can create processing servers at a snap of a finger that can process the batch of images that get uploaded. And so what this means for our research community is, say you're out in the field, you have your iPad, you're out collecting data. With an internet connection, with a cell connection or a Wi-Fi connection, all you have to do is upload the images, and then they begin processing immediately. You don't have to run back to your computer and kick off a series of batch processing to process your data. All of that data gets processed immediately, and once it's in the cloud, it's available to your whole organization at once. There's no more uploading or sharing of the data. Once it's up there, it's up there. And so I know that we have research taking place in different areas, remote areas, urban areas, and just being able to simplify that data capture and process stage is just it becomes very powerful when you have it put it in the hands of these researchers.
Thank you, Jeremiah. Jarlath, there's a question that came in from Stacy that I think will be great for the broader audience here. So she asked, one of the biggest hurdles to implementing an active program is working with, high risk management department at the university, and that drones are using, highly controlled and restrictive practices, sometimes policies. So flying drones on campus, for instance, what are some of the tips that you have for working through this type of barrier? And also to add another question, what are some of the resources that faculty have to get certified or work with, the broader campus departments?
Yeah, well, first, Stace, it's been a while since we've connected, but great to hear from a familiar person, an old colleague. So one of the things that I think we did well early on is we actually brought campus risk management out to fly alongside us. And the thing about drones is once you get people outside and you get them flying them, everyone loves them. And in that process, we walk them through our flight checklist procedures, all of our safety procedures. We showed them our evasive maneuvers. And then we actually did some data collection on campus that was actually of value. We took a construction site and did some updated mapping, and it was useful to the contractor. So I think those types of activities where you can engage people and show them that you can operate safely is a nice way to get buy-in. When it comes to faculty sort of getting trained, so we think it's a good idea, although the FAA regulations have some educational exceptions, good idea to have Part 107, which is the FAA licensed UAS operators within the United States. That is just a textbook exam. You go to an FAA testing facility, it takes about an hour, and you pass your test. I would say that doesn't make anyone really qualified to fly a drone. It really makes sure that you understand those regulations. And the FAA has a lot of great materials online, and there's also many companies that offer sort of short courses on that if you're interested.
Excellent. Thank you, Jarlath. Jeremiah, questions come in about basically utilizing the cloud to process imagery. Do you have to wait in a queue? How does this work with with scaling? And is there a cap on the images that you can upload?
So one of the beauty of SiteScan is that as long as your SiteScan subscription is current, we allow unlimited processing and storage of your data in the SiteScan cloud. So we want to make sure that there's no thought process in your head, or like, oh, should I process this data? You should always be uploading and processing the data, just because it's there and you have unlimited processing. One thing that I kind of touched on but didn't fully explain is the scalability of the cloud, and that means that when you upload those batches of images, say you flew 2, 3, 4 times, each one of those images are going to get its own processing server essentially assigned to those images. So Lane had mentioned queuing. We don't actually have your data is not getting queued in processing. They're all getting processed simultaneously. It doesn't matter if you have 1 pilot, 2 pilots, or 20 pilots. So that's just kind of a as I guess weight off the shoulders from a timing perspective. You don't have to worry about somebody else's data getting processed before yours, or one flight getting processed before the other, just because it's all streamlined. It's all running in parallel.
Yeah, absolutely. And kind of to that point, Jeremiah, thinking Jarlath about kind of ways to take that initial output and then maybe leverage it into additional analyses utilizing geospatial software and that higher spatial resolution. Could you give us a couple examples of ways that you've done this in your class with students to understand, now that you have the imagery products, what's the next step?
Yeah, and I think what's really exciting about drones, right, is we can go out to an area that we know and we understand. We can, for example, take a look at different tree species or different types, and then we can fly different sensors, and then we can look at those data and we can pose questions to them as why do they look this way? And then what's wonderful with all of the great information you folks have in the Living Atlas, right? We can stream in NAPE imagery or Landsat, and we can really help the students understand the benefits of spatial resolution, the benefits of having additional spectral bands in Landsat, and understand the trade-offs and limitations of all these different platforms. The drone may be great for getting high spatial, high temporal resolution imagery, but the footprint is really small. So from an educational perspective, we can really bring that out. And it also allows us to get to the idea of when should we use automated feature extraction? And I often sort of pose this to my students, think how long it's going to take you to spin up your object-based or AI system to count all the trees in this image. You'll be done with that in a manual method far, far sooner than any automated system. And so automated approaches are great, but they're not the appropriate solution in all cases.
And that makes me think too about a question that just came into the chat that kind of is in line with this, and that's about accuracy. Not just accuracy perhaps with the models that we're creating, but accuracy with the drone collections themselves. Jeremiah, would you mind speaking a little bit to ways that we can ensure that imagery is more accurate?
Yeah, accuracy tends to be a rabbit hole, but let me, give my little elevator pitch on drone accuracy. So when you're collecting data yourself, and you need to think about how, number one, how the data is being collected and how accurate the sensors are that is, taking place during the collection. There are a number of different ways to solve the accuracy problem. So first of all, if you go out and you fly and you create an ortho or a 3D model, that model is going to be accurate within itself. It's going to be fairly accurate within itself. However, the second you place that orthomosaic on top of your GIS or on top of a base map, you're going to see a little shift, a 1 to 2 meter shift, and that's just due to the inaccuracies of civilian GPS. There are a couple different ways you can counteract that. One is by placing targets on the ground. We call these ground control points, and these are essentially, a lot of times, they're white and black tiles that can be seen from the drone, and each tile has a location. You can use a high-grade GPS to get a location on those tiles, and during processing, you can assign photo pixels to those tiles, and it basically looks like a big spider web where you have 5 or 6 photos that can all see that one tile, and you're essentially snapping that data down to that survey point. That's one way, and that's a tried and true method. We've been doing that method with drones for years, but we're starting to see hardware, software solutions to this, like RTK or PPK enabled drones. So RTK, or real-time kinematic, using essentially the internet or other wireless stream to correct the innately inaccurate GPS and the drone to create very accurate photos that can essentially be dragged and dropped into processing to create very accurate data. PPK, or post-processing, essentially uses a GPS file to post-process the images after the flight is complete to enable them to be more accurate. When do you need accurate data? Well, this is a question for your specific use case. Like I said, if you just need an image from the sky, a map of the sky, you don't necessarily need that to be, sub-inch accurate. Maybe you don't need to go through the process of laying ground control points or purchasing an RTK enabled drone. However, if you're going to be doing any scientific experiments or flying multiple times over the same area, that's when you're going to want to ensure that your data is as accurate as possible and kind of overlays with other data sets or other models that you might have.
Awesome. Thanks, Jeremiah. And so just in the last few minutes here, Jarlath, if you could go back in time and start your program all over again, are there some things that you would do differently, or perhaps as you're providing this advice to others that are just getting started, what are some of those considerations that you might provide for us today?
Yeah, thanks, Lane. And I think most of the stuff we did pretty well, and I'm not sure if that was by intelligence, intent, or just dumb luck. Certainly, we had some close calls. I remember doing flight planning once in an area with a lot of topographic relief and not setting up the automated flight plan to account for the terrain. So luckily, the drone sort of threaded the needle through some tree branches during a leaf-off season here in Vermont, so I would have paid more attention to those things. I think the stakeholder buy-in was really important. That was something that I felt we did well early on, and that was across the board with our legal team, our risk management, and on the educational side, and making sure that people can see this as bringing value to the institution. And then I think it's really a nice opportunity for us to step back, and drones bring back in many ways the early days of remote sensing, right? And if you go back and look at the old types of photo interpretation work that was done, how did people identify a white pine, for example? It wasn't done based on a spectral response. They really understood the structure and texture of that species. And I think it's a wonderful tool for bringing back tradecraft. And then it's, as I mentioned, it's a great way to illustrate the trade-offs between different sensors and different processing methods. For example, just looking at the differences between structure from motion from a drone, which can be very high resolution, and then comparing that to perhaps active sensing such as LiDAR. What a unique way to understand how our different sensors and how our different processing settings affect what we see on the landscape. Because it's not just about the methodology, so much is about the small decisions that you as the analyst make along the way in your flight plan, in your choice of the platform, in your processing algorithms, whatever it is that impact your analysis at the end.
I think that's very well said. And I want to thank everyone for their time attending today, and our panelists for their experience and sharing their best practices and tips and tricks. If you please would stay, we have a 5-minute break that we're going to start now for the next session. Thank you so much for your attendance. And thank you, Jarlath.
Thanks, Lane.